Jai Hind viewers, welcome to AKGEC Digital School. My name is Pankaj Singh, faculty of IT department. Today I am delivering my video lecture on topic disk scheduling. It is a topic of operating system. So let us start. First of all, we must know what is the meaning of disk. As all we know, it is a storage device that is used to store information in a machine. So first we will take the definition of magnetic disk. Magnetic disk is a storage device that is used to write, rewrite and access data. It uses a magnetization process. We are here discussing the algorithms, not the actual designing parameter what are required for a magnetic disk. Okay. In this architecture, what it contains? It contains the entire disk is divided into platers, just like a plate as we see. Secondly, each plate consists of concentrated circles called a track that is used to store the information, and each track is divided into number of sectors, and a cylinder is formed by a combination of these track. When we put this track one by one at one plate to another, we form a cylinder. Now we have a overlook of their architectural design here. As I said, we have a track in a plate. First of all, we have a magnetic plate in which there are number of circles. These circles are known as track. Further, these track are divided into number of sectors like this. Further division. And when we put these plates in a cylinder, or we can say on a rod one by one, it form a cylindrical, and that is used for combinationally to store the data for read and write purposes. So today our concern is the algorithm which is used by operating system to read or write the data from these magnetic disk. Magnetic disk architecture contain what features? I read once here. There exists a mechanical arm called read and write head. All the operations on a magnetic disk is done by the help of a mechanical hand that's known as read and write head. Secondly, it is used to read from and write to the disk. It do the both work, read and write over the disk. Head has to reach at a particular track and then wait for the rotation of the plater to identify or locate the specific location or information from the plate. The rotation causes the required sector of the track to come under the head. When the required track come under the head, it will take the information or write the information vice versa as per requirement or as per the instruction given by the operating system. Each plater has two surfaces, top and bottom. Both the surfaces are used to store the data. In magnetic disk, track is used by both hands. From the top, we also read and write, and from the bottom side, we also read and write the information in this mechanism. Each surface has its own read and write head, just like it is a magnetic disk plate over where there are reading head for the upper surface. Likewise, there is another reading head for the lower surface, right? This process is done to read and write the data, or we can say to fetch and write the data over the magnetic disk. So why we need scheduling? First of all, we must know here, because there are many operations running in a machine that is controlled by operating system relevant to read and write operations. So all the operations relevant to the read and write operation is managed by the help of operating system, and this is done by the help of disk scheduling. What is disk scheduling? Disk scheduling is a technique used by the operating system to schedule multiple requests for access the disk. For example, at a time more than one user want to read or write the information from the magnetic disk. So how it will be managed? Who will access the first and who will access the second, and what data will be read and what will be write, it is all done by the help of operating system. For doing this, it required to manage disk scheduling. For doing these operations, a disk scheduling algorithm is required. There are different type of disk scheduling algorithm that are used in a operating system to manage the efficiency or working of a disk, magnetic disk, and the selection of scheduling algorithm is diagnosed on the behalf of as per the requirement of a user application to access the magnetic disk. But there are few by default algorithms that are implemented to access the magnetic disk as per the instruction of the operating system given by the user. What will we do in a disk scheduling algorithm? The algorithm used to disk scheduling are called disk scheduling algorithms. The purpose of disk scheduling algorithm is to reduce the total seek time. What is seek time? The time required to access the information or movement of head from one location to another. As we go into detail, how to manage the seek time or how to calculate the seek time. For example, if head position is 53 or we can say 50 and the next data that want to be read that is at 200 and again it is 60. So how it will manage? Either it will go first to the 60 or it will go to the 200. That is done or helped by the help of scheduling algorithm. So scheduling algorithm will help in to identify the exact method that will minimize the time to access the current location or current track position over a disk. For identifying this, here we have only 3 positions, but in actual if there are thousands of locations where read and write is done, so we need a mechanism that will use a best and suitable method by the help of which the access time of a location or read and write will minimize. For doing this, we use different algorithms and this is done by the help of scheduling algorithm in which we focus how to minimize the seeking time or access time that will take from one head location to the another location. For doing this, we will go with the help of examples in detail. First of all, we know how many type of algorithms, disk scheduling algorithm we use in this method. As over the screen, disk scheduling algorithm is divided into 5 categories as we see over the screen. First one is FCFS, first come first serve algorithm. Second one, shortest seek time first algorithm. Third one is scan method algorithm. Fourth is C-scan algorithm. It is just a extension of scan algorithm. If we go more technically or refined form, only there are first, second, third and fourth. It is a actual algorithm, that is just a extension, or we do some amendment into the actual working of a scan algorithm, and same is do in a look algorithm case. C stand for circular. So now we will take the definition of given algorithms, their advantage, disadvantages and one example for each to understand the exact working of a head within a machine, how it will move from one head location to the another. So now take the first algorithm, that is FCFS. As the name define, how it work? FCFS is a disk scheduling algorithm in which the first head location will access as per their arrival or as per their request. For example, first head location is 60, next is 300, next 50, 10, 400. Likewise, in this method there is no special mechanism used. As the name define, the FCFS mechanism will use, the head will move 60 to 300, 300 to 50, 50 to 10 and then again to the 400. In this, arrival of a request is considered, or we can say as the request sent by the operating system to read any specific location is read by its arrival or in a request mode. There is no change into the access time of a head location. So there are some advantages and disadvantages of this mechanism. It is simple and easy and very easy to implement, because there is no specific mechanism is implemented to switch from one head location to the another. It does not cause starvation problem, because in other method, if we use some mechanism, for example, if we go to the first left side and then to the right side, in this case the head location that are lie in a right side, that will wait until head will move all the left side position. So starvation problem may arise if any location or any requested wait for more time. But along with, if we use a simple mechanism, there are but obvious few disadvantages, like it result in increased total seek time. As we see in a very little example, if we first go 60 to 300, then 50, then 10, then 400, it will take more time as compared to the other method, as we discuss in a example in detail in a next slide. So it is a brief, or we can say a introduction of FCFS in term of advantages and disadvantages. Now take an example of to understand in detail how FCFS will work. Here an example in which cylinder locations are like 98, 183, 41, 122, 14, 124, 65 and 67. It is done by the help of FCFS. So how it will execute or how it will drive? First of all, we will make a timeline of all the cylindrical locations. So as in a numerical it is given, that is 0 to 129. So we make a timeline from 0 to 199. After that, we will mark the locations as given in a numerical in a increasing order, like 14, 41, 53, 65, 67, 98, 122, 124, 183 and last one is 199, that is given in a numerical. So how it work? As I said, it is a very simple mechanism. The initial head location is given, that is at 53, that is given in a question. The initial head location at 53. So how it work? It work as the arrival or as the request. First it will go up to 98 location, 98. After that it will move to the 183. After 183 it will move to the 41 and so on. After 41 it will move to 122. After 122 it will move to 14. As we see, as I discussed in a previous slide, what are the disadvantage? It increase the total seeking time of a algorithm. How it will increase? As we see in a given example, when a head move from 183 to 41 and it will go back to the 122. In another method or in another approach, we can do a method, we make a division on a behalf of left side and right side, and first we go to the all the right side locations and then we will go to the right side, left side. By doing this mechanism, we can easily minimize the latency seek time of a algorithm. So it is a disadvantage of FCFS, and advantage of this algorithm, it will execute and easy in a way as the request arrive to the machine. So now calculate how to calculate the seek time of algorithm. As we see in a given diagram, it will start to the locations. It will find out from the, if we talk about their seeking time, that is 98 minus 53. 98 minus 53. Likewise, For the second location, that is 183 minus 98 and so on. It will calculate it and finally we will get the seek time, that is 632 for a given head locations by using FCFS method. Calculation is very simple. We only required to subtract the previous head location from the current head location like this, and it will go to the next location and so on up to the last head location as given in a question, that is 67, as we see in a given solution. So by using this method, the seek time is 632. And now we will take the same example by using second method, that is known as SSTF, shortest seek time first. As the name define, in this method we prefer the head location that have minimum seek time, or as we can say, we will make a order list in a ascending order of the head movement from one location to another. We will take the example and understand into a form of their diagram. So first we will take the definition. As the name define, this algorithm serve that request next which require least number of head movement from its current location. So for example, if head location is 60 and next head movement is required, that is 170. In FCFS, it will move 60 to 100 and then move to 70. But in shortest seek job first, as the name define, the head will move to the minimum, or we can say the least number, or where the least movement of head from one current location to another. So where is the least movement? In this case, that is 60 to 70. So it will run like 60 to 70 and then 100. It is a basic difference between FCFS and SSJF, as we see by taking a very short example. Now we will take the same example by using shortest seek time first method. Now have a look over here. In a graph, as we see, the head location is 53. So in this method, we will make the, as I said, in a ascending order list, that is head location is 53. After that, it will go to the 65, then 67, then 98. After that, when it is at 67, it will calculate the difference between the next location, that is 98 or 41. Which one is nearer? It will go to that head location, right? So according to it, the next location will be 41, because the difference between 67 to 98 and 41, the difference between 67 to 41 is less as compared to 98. And after that, it will go to the 41 to 14 and it will move again to the 98 and 122, 124 and finally move to the 183. And the calculation of seek time is done by the same method. The first, we find out the head location, that is at 65 minus the previous head location, that is the initial head location as given in a question at 53. Likewise, for the next calculation, the current head position is at 67 minus the previous head position, that is at 65, and it is done as the same method as we do in a FCFS. And as we see, the seek time is 236 for the same numerical as we do in a FCFS. In FCFS, seek time is 632 and in SJF the seek time is 236. So it is very easy to understand which method is best to move for selection of head from one head location to the another head location. So it is one of the best method that is suitable for access the read and write operations in a magnetic disk. Now we will move to the third method. As the name defines, it is a scan disk method. What is done actually in this method? In this method, once head start move to the right side, it goes to the right and come back to the left side. Means it will follow only one direction at a time and covered all the head locations that lie in which side. As we take here definitions, head start from one end of the disk and move towards the other end, serving all the requests in between. For example, it can also move in a reverse order. First it will go to the left side and then it will go to the right side, but at a time into a one direction as the head locations given in a question. So it will never switch like SJFS and FCFS. In this method, as we see, first it will go 53 to the 65, 67 and then it will move to the 41. No, in this method either it will go in a right side or either it will go into a left side. Once it cover to the last location in a disk and then it will come back to the another end. Now take the example. As we see, it covered all the head locations that lie into the right from the current head location. What head location we have? 65, 67, 98, 122, 124, 183, and it will go to the last address. What is the last address? That is 199. Actually it is 200. We count it from 0 to 199. So it will go to the 199 and then again go to the other side endpoint. What it is? That is 0. In between, if any head location is left in a other side, like 41 is left, so it will covered and go to the last head location. So this method is also fast as compared to the FCFS, but it is compatible and best approach when there is a number of head is more as compared to the FCFS method. In this method only two calculations is required. Why two calculation? Because the head is start from 53 to the 199. 199 minus 53, and in another direction it will move from 199 to the 14 and then go to the 0. And then we will calculate the value of seek time, that is 331. And what is in FCFS? That is 632, and in SSJF it is 238 something. So we can also say that this method is also good for calculation of the head location. And another method is a C scan. What is the basic difference between scan and C scan method? In this method, for example, the head location is 53 and initial address is 0 to 199 and last location is 183. So in a previous method, or we can say in a scan method, it will move from 0 to 199, but in case of C scan it will move from 53 to only 183. That is C scan method, and it will move into another direction only till the head location, that is the last, that is 14. But in a C scan in a scan method, it go to the 0. That is a basic difference between scan method and C-scan method. If we talk to the same numerical, in this the subtraction will done from 183 minus 53 and 183 minus 14. As we see, the difference will automatically decrease. How much it will decrease? Here there are 16 and 16, that is 32. It will be a 299 if we use C-scan method at a place of, if we use C-scan method at a place of scan method. So the difference hopefully is clear, because the movement of head will minimize the seeking time, but into a previous method it will go to the head location to the extreme last location on the right side, and similarly from the right location to the extreme left location, or we can say to the last address location on a track. After that, one more algorithm, that is a look disk scheduling method. Look algorithm is an improvement version of a scan algorithm. Head start from first request to one another end of the disk and move towards the last request at the other end of a request in between. After reaching the last request of other end, head reverse its direction. It then return to the first request at the starting end. All the requests between them, the same process will repeat. What are the advantage? It will save the time, and the same thing is done in a, it is a example as we see, that will start from 53 to the 183 and it will move till 14, as I discussed in a previous example. Now what is CLOOK? In this method, at a time head will move in a one direction, like 53 to 183. Then it will not read any address when it move to the another location, and start again reading to the remaining head location that lie into the other portion of a starting head location to the another head location. So it is a basic difference between CLOOK and look method. Hopefully it is clear to all. Thank you. Meet again in a next video lecture.